Assalamu alaikum everyone, peace be unto you all. So I'm making a series of videos now due to I'm thinking that a lot of people require help um, with this subject, and I just want to help you guys because I think I understand this quite well. So this is my first video. So it's this video is just going to give you a little bit of introduction and a little bit more knowledge about truth tables. Okay, so truth tables are basically just a way for us to have a logical reasoning about two or more propositions, which includes variables. And these variables could be pretty much any letters. Most likely they will be letters, and they could be capital letters, and they could be small letters. And for example, P, capital P, is a different variable than a small p, and you have to understand that. Okay, and let's come straight to the rules. So there's just pretty much one rule, which is which we're going to do right now. So you look at the number of variables given to you in any equation, proposition, anything. You just look at the number of variables, and you can put it in this format, or you can just keep it in your head. So in this, for example, they're going to be 3. In this example, they're going to be 4 variables. All you do next is just raise 2 to the number of variables that you have in your proposition or equation. So 2 to the power of 2 will give you 4. So this 4 makes you remember how many rows you're going to have. So let's just put this here. 3 and 4. So this means that you're going to have 4 rows here. So if we do this, you're going to have 3 variables, and 2 to the power of 3 is 8. So you're going to have 8 rows here. So you can put those here. Those and 8. Here we have 4 variables, right? So 4 here, and 2 to the power of 4 is 16. So we're going to have 16 rows. That's how you work out the number of rows. It's basically you count how many variables you have, and then you raise it to the power of 2, and the number you get is going to be the number of rows you will have for that equation. So you can do this, and this would go up to 16. Okay, 16. Okay, now I'm going to help you and let you understand how you basically fill in this table. So you'll always first of all start from your right hand side. So in this variables basically, you start from the right side and you do like this. For example, you do T for true, false, true, false. That's for Q. And for P, you go up by ones, so it'll be T, F, F. So this just alternates. So the truth value here alternates once. Here it alternates twice. So there'll be 2 T's, 2 F's. And as you have guessed, it's going to be pretty much the same, but just a little bit different in this one because we have 3 variables, so it's going to go 4 times in this row. So it's going to be T, F, 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 T, F, T, F. Okay? And in this row, you're going to have T, T, F, F, T, T, F, F. And in this row, you're going to have T, 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 F, 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 F. Why we do this is to make sure that we have all of the combinations that these values can have. So this proposition, so all of the variables could be true, and all of the variables could be false, and all of them in between. Same here, all of the variables could be true, and all of the variables could be false, but they could also be this. One can be true, the other can be false, and they could form all these combinations. So we want to see whatever we get, which I will show you next, can actually happen through these as well. Okay, so in this set of variables, it's going to be the same thing. So TF, 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 TF. So you carry on like this, and then now you're going to alternate it twice. So T, T, F, F, T, T, F, F, T, T, F, F, T, T, F, F. And here you go 4 times T, T, T. You go F, 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 T, 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 F, 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 F. And you can actually see so here you do it 8 times, so T, 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 and the number helps as well. And then here F, 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 F. Okay, and what this would do, this can help you now to understand. So this is how you lay out the table, and now what we're going to do is we're going to go into the next bit, which is this, and understand how you can do this. So here I have to show you this example. It's pretty simple, but so I've used basically 2 variables just for you to understand. And this is the essential bit. You have to understand these tables, because most of the questions you can just do them in your head just like that, by just understanding this table. So first we have an AND table. This is like a sort of a triangle, and basically it's an upside down B. Pretty much stands for an A without the middle line. And you have to understand this table. So I've already filled this out like TF, TF, and then TT, FF, because remember we have 2 variables, and 2 to the power of 2 is 4. So the AND table is only true once, which is when there are 2 T's. Every other single possible combination will give you false in the AND table. In the OR table, every single possible combination will give you true, except when you have 2 F's. So it's the opposite of AND table. And in the AND table, you have only when you have 2 T's will give you a true value. Everyone else you're gonna get false value. In the OR table, you will always get a true value, except when you have 2 falses. Negation is the easiest. Oh, by the way, OR table or symbol is the V sign. In negation, it's like a corner of a cube. So in negation of P, for example, that's what this says. Negation of P. P is this. So we just flip these values. Flip of truth is false, false. Flip of false will be truth, and truth. Q is this, and negation of Q is just flip these values. So flip of T would be false. Flip of false would be true. Flip of true would be false. And flip of false would be true. That's what you have here. Now implication table. Implication stands for this arrow symbol, and this is one of the hardest, but once you get your head around this, it's going to be easy. So implication will always be true. Will always be true, except in only one condition, which is when the left hand side here is true and the right hand side, which is here, is false. That is the only way in which the implication table will give you a false value. So this is the one you need to get your head around. This it's more or less like an OR tables. You will always get a truth value. The only way you will get a false value in your result would be because of this, when you have a true on the left hand side and false on the right hand side. So thanks a lot guys for watching, and this has been a video about truth tables. Make sure you go over it, and I will show you examples in the next video that you can do using these techniques. Allah.